Pancreatic lipase in the small intestine is the principal enzyme that will break down triacylglycerol to produce monoacylglycerol and 2 fatty acids. The latter, smaller molecules derived from triacylglycerol can now be absorbed by the intestinal mucosa. The absorbed lipids, the fatty acids and monoacylglycerol inside the intestinal mucosa will then get reassembled into a triacylglycerol molecule, very similar to the ones that originated in the lumen of the small intestine. Chylomicrons are lipid particles assembled in the intestinal mucosa, and their composition reflects the composition of our dietary lipids. They're 85% triacylglycerol and about 15% of cholesterol esters and phospholipids. The apoprotein ApoB48 helps in the release of chylomicrons into the lymph and eventually the bloodstream. During their passage in the bloodstream, chylomicrons are acted upon by lipoprotein lipase associated with the endothelial wall, releasing 3 fatty acids which are picked up by neighboring tissue. During fasting, the second important energy source needed in the bloodstream are fatty acids. Fatty acids will be derived from stored triacylglycerols in adipose tissue. This is accomplished through the activation of hormone-sensitive lipase, which is enriched in adipose tissue and is activated by epinephrine. Hormone-sensitive lipase gets phosphorylated by protein kinase A, which is in turn is activated by activation of the beta adrenergic receptor by epinephrine. This results in the release of 3 fatty acids from triacylglycerol and glycerol to the bloodstream. It is noteworthy that hormone-sensitive lipase in adipose tissue is only activated by epinephrine through the beta adrenergic receptor. It is not activated by the glucagon receptor because adipose tissue lack a glucagon receptor. It is also noteworthy that tags stored in adipose tissue represent a significant amount of fuel reserves for various tissues during fasting, and the lipolysis of these tags and availability of circulating fatty acids is essential for maintenance of the energy needs of several peripheral tissues during the fasting state. If you like this video, please subscribe. Thank you.